Okay, so this lesson is reviewing solving linear equations. So at this point, there are no more brand new lessons. All of the new learning is done, and all the lessons from this point forward are all going to be review lessons to prepare you for Algebra 1 next year. So I just want to do a little refresher since it's been a while since we solved linear equations, but hopefully after watching this video, you'll remember how to do that. Okay, some of the things we're going to talk about in this video are the steps to solve linear equations. And then we're also going to talk about how to determine how many solutions a equation will have based on what it looks like. Okay, so first let's talk about the steps to solve multi-step equations. Okay, so this will vary depending on how many steps your equation will have, but in general, this is the order that you use to solve multi-step equations. So number one, look for the distributive property. So the distributive property is when you have a number sitting outside of parentheses that can be distributed or multiplied to everything inside the parentheses. Okay, that needs to be done first. Once you've done the distributive property, you're going to look for like terms, and we're going to combine them. Remember, like terms are on the same side of the equal sign. Like terms have the same variables in them, and they can be added together. Once you have your like terms combined, you want to get your variables on the same side of the equal sign. So whether it be x, z, whatever the variable is, we want to move them to the same side, and we do that by adding or subtracting. Okay, remember, in order to move across the equal sign, you have to do the inverse operation. So if it is a positive, you need to subtract. If it is a negative, you need to add. Okay, then we worry about our constants. Constants are the numbers that are by themselves. Okay, we want to move them away from the variables and get them on the other side, also by adding or subtracting the inverse operation. Okay, and then lastly, we're going to move our coefficients. A coefficient is the number in front of a variable, and we are going to move those by multiplying or dividing. So for example, if I have 2x, 2 is the coefficient, and to separate it from the x, I would have to divide by 2 because that's the inverse of multiplication. 90% of the time you will be dividing in your very last step, but there are some cases where you will be multiplying. Okay, so I have this little check sheet here, and if you struggle with solving equations, you may want to use this as you're solving your problems in this lesson. Okay, you can use it kind of as a check sheet. So looking at this, it says distributive property comes first, and I notice my 8 is outside of parentheses. So I need to distribute the 8 to everything inside. When you distribute, you're multiplying. So 8 times x gives me 8x. 8 times 2 gives me 16. And I don't distribute it to anything else because nothing else is inside the parentheses. So these are just going to come down. And I've completed my distributive property. Now I'm looking for like terms. So if I look on the left-hand side of my equation, I have 8x and 16. They are not like terms because both of them don't have x's. Okay, if I look on the right-hand side, 2x and 16 are also not like terms because they don't have x's on them. So there are no like terms for me to combine. So I'm just going to cross that out. I don't have that to do. Okay. Now I need to get my variables on the same side of the equal sign. So that's why I drew my line down the middle, okay, right down from my equal sign. I want to get this 8x and this 2x on the same side. Now they're both positive, so I know I'm going to have to subtract. So I get to decide, do I want to subtract 8x from both sides or do I want to subtract 2x from both sides? I normally go with the smaller of the two. So I'm going to subtract 2x from both sides. Okay, and remember, you can only subtract from its like terms. So 8x minus 2x is 6x. Okay, and this plus 16 can just come down because we haven't touched that yet. Now 2x minus 2x is 0, so we can cross it out, and we still have 16 on the right-hand side. So now my variable is all on the left-hand side. So the variable is ready to go. So now we have to move the constant. So the constant is the number that's by itself on the same side as the variable. Okay, so in this case, our constant is this 16. Okay, this one right here. Okay, so we want to move it away from the 6x. So since it was a positive 16, The inverse of positive or adding 16 would be to subtract 16. And whatever you do to one side, you have to do the same thing to the other. So we know 16 minus 16 is 0. So we have 6x equals, and then 16 minus 16 is 0. So my constant is moved away from my variable. And lastly, I need to move the coefficient. I need to move the 6. So 6 is connected to x by multiplication, so the inverse would be to divide by 6. Okay, these are going to cancel out because 6 divided by 6 is 1x, or just x. And then 0 divided by 6 is 0. So this is my final answer. So I've done all the steps. If I want to go back and double check, I can substitute 0 into the original equation every time I see an x. And my left side and my right side should be equal to each other. Okay, this one has one solution. All right, in this problem, again, we're going to start with distributive property. So this time we're distributing the right-hand side. So I need to distribute 4 times 2x. Okay, 4 times 2x is 8x. And then 4 times negative 1 is negative 4. Okay, so I've done the distributive property. Combining like terms, I'm going to move there next. I can't combine 8x and 4. They're not like terms, but I do notice that 3x and negative 1x are on the same side, and they can be combined together. So 3x's minus 1x gives me 2x's, and then I still have my plus 4. So I've combined like terms. So now we need to get our variables together. So I have 2x on this side, I have 8x on this side, draw my line down the middle, and I'm going to decide to move the 2x. So since it's positive, I want to subtract 2x from both sides. All right, 2x minus 2x is 0. So I have 4 equals 8 minus 2 is 6x minus 4. Okay, so my variable is now on one side. All right, the constant that's on the same side as my variable this time is the minus 4. So in order to move that to the other side, I have to add 4 to both sides. So I have 8 equals 6x. So my constant is now moved. And my last step is to move the coefficient, or the 6. So I need to divide by 6. Okay, so I can simplify 8, 6. Now, if I do 8 divided by 6 in my calculator, I'm going to get a decimal. I end up getting 1.3 repeating. So you can either say 1.3 repeating with a Repton bar, or you could also simplify 8, 6. So if I have 8, 6, and I say to myself, what can I divide both of those numbers by? The biggest number I could divide them both by is 2. So 8 divided by 2 is 4. 6 divided by 2 is 3. So 4/3 would also be an acceptable answer. So I can say x equals 4/3. So either one of those answers would be fine. Okay, and again, because we get x equals a number, this one has one solution. All right, so now I want to talk about how many solutions. So if you get x equals, or a variable equals a number, for example, like this one here, when you get x equals 5, that means there are there's only one solution. That's it. That's the only number that's going to be able to work in that situation. Okay. Infinitely many is when you cancel out your variables and your very last step looks something like the one in the middle, where you have -4 equals -4, or you get a true statement. -4 is equal to -4. They're exactly the same. So because it is a true statement, you would have infinitely many solutions. Okay, now this one on the right has no solution because 7 is not equal to -2. That's not true. That's a false statement. So because it is not true, then there are no solutions. Okay, so just take a look at your very last step, your final answer. If you have a variable equals a number, it's 1. If you have a true statement, it's infinitely many. If you have a false statement, there are no solutions. Okay, if you have any questions, feel free to reach out to me on Blackboard Collaborate, and I'll be there to help you.